Okay, let's go take a look at book.
2050 वाले GPU लैपटॉप कितने के आते हैं?
अभी उसको दिलवाया था 453 का।
ये तो 44 का दे रहा है।
आप कम हो गए है ना प्राइस।
Acer Aspire
हाँ
7
वही दिलवाया था।
अच्छा, Intel Core i5 12 जनरेशन किसको?
वो ऋषभ के कजन को।
और ऋषभ ये का आदमी कौन सा?
तो 2050 वाले ही है,
क्या नाम है?
पता नहीं, एसर का ही है, 12th जनरेशन वाला ही है। Okay,
60 महंगे आते हैं।
शायद। So any changes you make to XML layout is reflected in Android Studio. Let's have a closer look at the design editor. The design editor presents you with a more visual way of editing your layout than editing XML. It features two different views of the layout design. One shows you how the layout will look on an actual device. The other shows you a blueprint. Right? This is the blueprint. Blueprint of its structure. Okay, if Android Studio doesn't show you both views, click on Show. Okay, right. The view of the design look at an actual device, and this is the blueprint which focuses on the layout. Do I have that? Android Studio. Yes. Then to the left of the design editor, there is a palette that contains components you drag to your. Okay, right. We'll use this next. This list shows you different categories of components you can add to your layout. You can click on them to filter the components displayed in the palette. These are the components you'll find out more about them later in the book. Meaning you can increase the size of the palette by clicking this area. Add a button using the design editor. We're going to add a button to our layout using the design editor. Find the button component in the palette, click on it and drag and drop it into the design editor so that it's positioned above the text. The button appears. Let's do that. The button, and we drag and drop this, and we want this to be beneath. So this is above. Changes in the design editor are reflected in the XML. Dragging GUI component to the layout, like uh, dragging GUI components to the layout, like this is a convenient way of, like this is a convenient way of updating the layout. If you switch to the code, you'll see that adding the button via design editor has added some lines of code to the file. Okay, so there's a new button element that describes. We see, yes, we have this button, ID button, then mass parent, wrap content, and video text. Yes. Okay, there's a new button element that describes the new button you've dragged to the layout. We'll look at this in more detail. The, the code the design editor adds depends on where you place the button. So don't worry if your code looks different from ours. Okay, so activity kind has a new button. The editor added a new button. A button in Android 12 is a push button that the user can press to trigger an action. The button element includes properties controlling its size and appearance. These properties aren't unique to button. Other GUI components, including text views, have them too. Okay. Buttons and text views are subclasses of the same Android view class. This is a very good reason why buttons and text views have properties in common. They both inherit from the same Android view class. Okay, so Android ID. This gives the component an identifying name. The ID property enables you to control what components do via activity code. Right. Okay. Then the view class includes lots of different methods. Later in the book, then Android view.view set ID. Text view is a type of view. Android.widget text view. Text and button is a type of. Okay. So which means it is also a type of view. Type of text. Android layout width, Android layout height. These properties specifies the width and height of the component. The wrap content means it should be just big enough for the content, and match parent means it should be as wide as the layout containing it. Okay. So wrap content width button is match parent. So it's okay, Android text. This tells Android what text the component should display. In the case of button, it's the text that appears on the button. Layout heights, layout. A closer look at the layout code. Let's take a close look at the layout code and break it down so that you can see what it's actually doing. Don't worry if the code looks a little different. The linear layout element. This is the button and the linear layout element. The first element in the layout code is the linear layout. The linear layout element tells Android that the different GUI components in the layout should be displayed next to each other in a single row or column. So we can say that it has vertical means they will be stacked, right? We specify the orientation using the Android orientation attribute. In this example, we're using vertical. So the GUI components are displayed in a single vertical column. There are other ways of laying out GUI components too. We'll find out more about the read and the okay, a closer look at the layout code. The linear layout contains two elements, button and a text field. The button element. First element is button. ID with as this is the first element inside the linear layout, it appears first in the layout at the top of the screen. Okay. It is a layout width of match parent, which means that it should be as wide as its parent element, linear layout. Its layout height has been set to wrap content, which means it should be tall enough to display the content that to display its text. The text view element. Final text view element. As this is the second element, and we've set the linear layout orientation to vertical, it is displayed the first underneath the button. First element. Its layout width and layout height are set to wrap content so that it takes up just enough space to contain its text. Changes to the XML. We've seen how adding components to the design editor adds them to the layout XML. The opposite applies to any changes you make to the layout XML are applied to the design. Try this now. Update your activity find peer XML code with the following changes. The highlighted in bold. Okay, so we add a spinner, then we made find peer wrap content, we add center the button horizontally and give it a margin layout gravity. Okay, this element displays a spinner in the layout. Okay, so let's add a spinner element. So we just this. Um, yeah, then we add Android ID equals at the rate plus ID color. We go Android layout with Android layout out Android layout with equals wrap content and Android layout height equals wrap content. Then we provide it with a margin at the top. The spinner is the Android name for the drop-down list of values. It allows you to choose single value from a selection. Right. We have layout underscore margin Android layout underscore margin dot equals 40 dp. Then we have Android layout underscore gravity center. Center. And finally, we have Android layout underscore margin. This equals to 16 dp. Am I right? Yeah. Then we center the button horizontally and give it a margin. Okay. So this is what this does. Give it a margin 16 dp with wrap content. Can't change button's ID to find pair, find underscore pair. Okay. Change the button's ID to find underscore pair. We'll use this later. Okay. So instead of button, find underscore pair, then Android layout margin 16 dp. Android layout. Okay, I also have to change the width to wrap content. Wrap content, create the gravity to center and hello text button. Change the button's width so it is as wide as the content. Then text view, we change the text view's ID brands. Okay. Change the text view and apply a margin. Okay. So we ID to brands, then we apply a margin and Android Sorry, margin. That's nothing. It is layout margin. Then we have layout, gravity, center, and this is the text view. We update the contents with right, reflected in the design data. Once you've changed the layout XML, switch to design data. Instead of a layout containing a button with a text view underneath it, you should see now a spinner button and text view centered in a single column. Okay, let's check it out. Yes, we have this, and this. Spinner is an Android term for a drop-down list of values. When you press it, it expands to show you the list uh, so that you can pick a single value. This is the spinner. This will let you choose the type of layer. The user will click on this button and the relevant layers appear. The GUI components such as button, spinner, text view have very similar attributes as they are all types of view. Behind the scenes, they all inherit from the same Android view class. Now, we've shown you how to add GUI components to the layout with the aid of the design editor, and also by adding them through XML. In general, you're more likely to hack the XML for simple layouts to get the results you want without using design editor. This is because editing the XML directly gives you more direct control of the layout. Let's take the app for a test drive. Okay. We still have more work to do on the app, but let's see how it's looking so far. Save the changes you've made by choosing File Save All, then run the app commands in the Run menu. When prompted, select the option to launch the immediate. Wait patiently for the app to load, and eventually it should appear. Try pressing the spinner. It's not immediately obvious, but when you press it, the spinner presents you with a drop-down list of values. It's just at this point we haven't added any values. Okay, let me turn it on. Then we start the app. Then we will. Okay, we should see something. Right. Checking time. Okay, there's nothing button. Next. So that here's what we've done so far. Here's a quick recap of what we have done so far. The spinner process value. Okay. So we've created a layout that specifies what the app looks like. The activity specifies how the app should interact with the user, but we have not specified done anything. Android Studio has created an activity for us, but we haven't done anything with it yet. The next thing we'll do is look at replacing the hard-coded string values for text value. Okay. My layouts look slightly different in the AVD compared with how it looks in the design. What's that? The design editor does its best to show you how the layout will look on a device, but it's not always accurate depending on what version of Android Studio you're using. How the layout looks in the AVD reflects how the layout will look on a physical device. Okay. Hard coding text makes localization hard. Make localization. So far, So far, we've hard-coded the text we want to appear in our text views and buttons using the Android text property. Yeah, so far we've hard-coded the text we want to appear in our text views and buttons using the Android text property. Well, this is fine when you're just learning. Hard-coding text isn't the best approach. Suppose you've created an app that's a big hit on your local Google Play Store. You don't want to limit yourself to just one country or language. You want to make it available internationally and for different languages. But if you've hard-coded all text in your layout file, sending your app international, sending your app international will be difficult. It also makes it much more harder to make global changes to the text. Imagine your boss asks you to change the wording in the app because the company's changed its name. If you have hard-coded all of the text, this means that you need to edit a whole host of files in order to change the text. Put the text in a string resource file. The better approach is to put your text values in a string resource file called string.xml. Having a string resource file makes it much easier to internationalize your app. Rather than having to change hard-coded text values in a whole host of different activity and layout files, you can simply replace strings.xml file with an internationalized version. This approach also makes it easier to make global changes to text across your whole application, as you only need to edit one file. If you need to make changes to the text in your app, you only need to edit strings.xml. How do you use strings resources? In order to use string resource in a layout, there are two things you need to do. Change the string resource by adding to the string file and use the string resource in your layout. Create the string resource. We're going to create two string resources, one for the app, one string name is app name, one for the text that appears on the button and another for the default text that appears in the text field. To do this, use Android's Explorer to find the file. Strings.xml in the app, okay, this value, app source main res values folder. Open it by double clicking on it. The file should look something like this. Okay, res value string. So here we go. Contain the app name which has a value. Okay, this is the ID and this is its value. Fine, here this is the ID and this is its value. Name which is has a value. Android Studio creates string resources for us automatically, and we've created the object. This indicates that string resource. This indicates that this is a string resource. Okay, string. Okay. The string resource. The string resource has a name of app underscore name and a value. This string resource has a name of app underscore name and a value of peer advisor. So first going to add a new resource called findpeer that has a value of findpeer. To do so, edit the string XML so that you add it. This adds a new string resource called peer. Right. So this comment in XML file. If this comments work the same, right? Okay. So in order add a string resource, follow the convention. भेजा भाई,
चलो
देख ले वो. Okay, so we follow the convention. String name equals ID. Then we have value. We have value, and we close it up. So we are going to add a string resource find here. String name equals find it here. This is the ID, and find it. Then add a new source called branch with the value new PS selected. String name branch with value no selected. No PS selected. This will be the default text in the text view. Once you've updated the file, go to the file menu and choose Save All option to save the changes. Next, we'll use the string resource in our layout. So, use the string resource at the rate string and then ID. We use string resource in a layout like this. You've seen the Android text part of the code before. It specifies what the text, but let's start with the first, the AND string. This is just a way of telling Android to look up text from the string resource file. In our case, this is the strings.xml file that you just edited. The second part tells Android to look up the value of a resource with the name find where. So the string find where means look up the string, look up the string resource with the name find where and use its associated text value. Display the text. We want to change the button and texture elements in our layout XML, so they use the two string resources we've just added. Go back to the layout file and make the following changes. Text right, string buttons is here, and the text view string branch. Like Android Studio sometimes display the values of the reference of the code editor in place of actual code. Okay. As an example, it may display that text find where instead of the real code. Any such substitution should be highlighted in the code editor. If you click on them and hover over them with your mouse, it will be revealed. Okay. Find where, no where. The code for activity. Here's updated code. We didn't need the spinner to change. We didn't need to change the spinner. We'll look at how to add value to different text pages. Create this way display. Text. When you're done, save your changes. We'll put a summary of adding and using string resources under the next string resources. The string.xml is the default resource file used to hold name value pairs of strings so that they can be referred throughout your app. There's a following format. The resource element identifies the content file as the resource. The string element identifies the name value pairs as a string. Anyways, there are two things that allow Android to recognize string.xml as being a string resource file. The file is held the file is held in folder app source minus values. XML files held in folder contain simple values such as string and colors. The file has a resource element which contains one or more string elements. The format of the file itself indicates that it's a resource file containing strings. The resource element tells Android that the file contains resources, and the string element identifies each string resource. Okay. This means that you don't need to call your string resource file strings.xml. If you want, you can call it something else or split the strings into multiple files. Okay. Each name value base takes the form this, where string names identify the string and string value is the string value itself. The layout can retrieve the value using this. String tells Android to look for a string resource of this name, and this is the name of the string value we want to return. Time for a test drive. Let's test drive it. Okay, let's see how's the app looking now. Save the changes you've made, then choose the run app command from the run menu. When prompted, select the option to launch the emulator. This time when we run the app, the text for the button and the text we has changed the string values we added. Here's what we've done so far. We've created a layout that specifies what the app looks like. The file strings.xml includes the string resources we need. The activity specifies how the app should interact with the user. We have not done that. Okay. Now we'll look at how to add a list of beers with experiment. They are not questions. Do I absolutely have to put my text values in string resource files such as string.xml? It's not mandatory, but Android gives you warning messages if you hardcode text values. Using a string resource file might seem like a lot of effort at first, but it makes things like localization much easier. It's also easier to use string resources to start off with rather than patching them in afterwards. Okay, how does separating out string fairly help with localization? Suppose you want your application to be in English by default, but in French, it's a language, set to French. Rather than hardcode different language into your app, you can have one string resource file for English text and another for French text. How does the app know which string resource file to use? Put your default strings into res values folder as normal, and your French resource file in a new folder values.fr. If the device is set to French, it will use the string tab next folder. If the device is set to any other language, it will use the strings in the okay. Add values to the spinner. At the moment, the layout includes a spinner, but it doesn't have anything in it. Whenever you use a spinner, you need to get it to display a list of values so that the user can choose the value they want. We can give the spinner a list of values in pretty much the same way that we set the text on the button and text view by using a resource. So far, we've added strings.xml to specify individual string values. For the spinner, all we need to do is specify an array of string values and get the spinner to reference it. Sources are non-code assets used. Adding an array resource is similar to adding a string. As you already know, you can add a string resource to strings.html. Okay. To add an array of strings, you should use the following syntax. Okay, string dash array, name string array. Then we give item. These values we can add as many as you want. String value 1, string value 2. The string array is the name of the array, and string value 1 to 3 are the individual string values that make up the array. Okay. Let's add a string dash array resource to our app that can be used by the spinner. Add the string array, let's light, amber, brown, and dark. Okay. String arrays also added to the resource as string dash array. Wait, string dash array. Name equals id. String dash array. We have item value 1, right? Right.
That's he.
That's
Smell of it.
okay. So I will be adding this string array. Yeah, item with values light, amber, brown, dark. Light, amber, brown, dark. Okay. Get the spinner to reference the right array. A layout can reference a string array using similar syntax to how it would retrieve the value of a string. Rather than use string, we use the syntax this. Okay. Whenever array name is the name, where array name is the name of the array. So we can go here in the spinner, set enjoy text, enjoy text, right? The array slash entries. Okay, sorry. Let's use this in the layout. Go to the layout activities and add an entry attribute to the spinner like this. This means entries for the spinner come from an array. This. Right. Those are all the changes you need in order to get the spinner to display a list of values. Let's see what it looks like. Okay, like that. Text is used. Entry. Entry. Slash what is the name? Yeah. Now, if we take a look, each values is not updated. Let's run the app. The spinner target size too small. What happened? Typo here it was. I don't think there's a typo here. Could explore spinner target is too small. Does that mean the item height is 24 dp? Consider making the height of this touch target 48 dp or larger. Layout height, wrap content. Let's see what it looks like. But it gives me an error. Not accept. Well, resource compilation. So it is saying that layout height resource compilation failed. The Java legal state do not extract resource entries entry equals to add array. The spinner is still okay. I did translation for all of the translation editor. This translation editor. Sorry. Identification. Yes. So where app debug resource validation failed. Weird when action but now then layout version documented traffic height height 40 dp. Does that work? AAPT compiler.fast resource layout and target sizes. Items height is 24 dp. Consider making the height of this touch target 48 dp or larger. Touch target size to small. Let's see this in motion. Okay, touch target size to small. layout weight. Okay, so we got too small. How can we fix that? It is literally okay. Any on-screen element that someone can click otherwise should be large enough for a reliable. Consider making sure that these elements have a width and height of at least 48 feet. When you implement clickable or touchable elements in the layout, consider using dimensions that meet or exceed recommended size for touch objects. If these control the size dynamically, precise based on their content, consider using min width and min height to set a lower bound on their dimension. To retain the original size, so Android, so I should upgrade Apple and I should update Android with height equals 48 HD. Wait, does this fix it? I have declared min height. Min height with that's double. This is should I delete these? String uh, separated by 8 tables space. To ensure balanced information is read twice about say cannot extract its source. Find and exchange dot symbols somewhere else in your code. Exchange all. Maybe many reasons why you get this error. All of them invoke problem with XML file in your values. Unfortunately, although you can open validated tools, some problems are not. But if you try to run tasks, the app must be output that. Do I have string string array, clear colors, light dark? I don't see a problem here. Then if it's like entries and here display colors. Oh, my bad. I will add these here. So try this. Execution failed for task. Failed ago while executing. First compression failed. Value. This values.xml. That's Java links. We cannot extract values.xml. I don't have a build intermediate. Okay, so there is something wrong with the values info. Failed. Resource comparison failed. Okay. The tools. Example action. No, there was the validate. Task. Inspector. Right. Okay, let me check. Media layout. Right. Find text. Spinner. Input voice manifest. There. The given errors. Sign. PDP. Over to exclamation. Okay. These are to be added. This everything. I don't think it changes color. Fifth color. Have I named it color? Yeah, I have named it color. Okay, select the button. Select the ID color. Brands. Like where it still don't understand. Let's see. Yes, we cannot extract resource to clear extended resource comparison before. This issue indicates that one of the source files failed to compile properly, which usually leads to a failed parenthesis. Go and explore the common causes and effects. Okay, so there's something wrong with my example. String starts here, string starts here, string starts here, and string array. Let me try and stick with this string branch and then start the string array. Here this, here this. Oh, okay. So it has items and after it has items. That was it. Item. So that was my mistake. And I feel like I won't be needing this. Right. Let's try. Launch my device. Yeah. Great. You can select bunch. Okay. Finally I got it. This item. My bad. Okay. So created layout that specifies text view and now string directory includes the string resources we need. The activity specifies how app should interact, but we haven't done anything with it. You need to make the button do something. You need to make the button do something. What we need to do next is make app react to the values we select in the spinner when the find beer button dot is clicked. Want the app to do something like user the user chooses the type of beer from the spinner. The user clicks the find beer button and the layout specifies which method to call in the activity. The method in the activity retrieves the value of selected beer in the spinner and passes it to the get grants method in Java custom class beer expert. Then beer experts get grant method finds matching brand for the type of beer and returns them to the activity as an array list of strings. List dynamic array. Then we have an activity gets a reference. An activity gets a reference to layout text view and sets a text view to the listing. After all these steps are completed, the list is displayed on the So I think this is it for today.